I'm currently a general manager within Venter. I look after 3 subject matter expert groups. So these are groups of really high-end scientists. And the 3 groups are, first of all, the group led by Anna Bevan, who sits there in the back. That's our food assurance science team. The second group is our consumer and sensory science team. And then the third group is our global nutrition team. What I'm going to do today is I'm going to talk to you a little bit about how we as Venter apply whole genome sequencing as part of our food safety risk management. Right. So I thought it best probably to start out way to what we expect of ourselves. Now this is the expectation that we drafted around about the time when Dr. McCulloch joined Venter, and that's about 4 years ago. And Dr. McCulloch is our global executive that looks after food safety, quality, and regulatory, and health and safety. So he's a very, very busy guy. But what he did is he created a good environment for us as food safety scientists to really develop and to grow within this space. And Greg said to us, what I want from you within Venter is I want us to create a specific expectation, and that's expectation of ourselves. And that expectation is that we will be able to deliver what matters most to both our customers and our consumers, to keep our promises and to show them what it is we stand for. Now, there's quite a bit of emphasis on showing them what we stand for and not telling them what it is we stand for. And what it is that he expected of us to show them is uncompromised food safety and world-class quality. And the expectation was that we could demonstrate this across our value chain. Now, within Venter, our value chain is fully integrated, so it goes all the way from the grass, which our cows consume, all the way to the final product, which the consumers will consume. And this, in a nutshell, we call trust and source. I don't know whether you in the back can see at the bottom of the slide pack here. Now, trust and source is built on a variety of pillars, and one of those pillars is our risk framework. Now, I thought what I'd do is I'll discuss this with you a little bit, and I'll show you where we apply whole genome sequencing currently within this risk framework. Our risk framework in Venter contains 2 distinctly different elements. The first one is what we call our risk management function, and the other one is what we call our risk assessment function. Now, this should be quite familiar to those of you that work on risk assessment, because this is based on the Codex guidelines of setting up a risk framework. Now, in the past within Venter, these 2 functions were quite distinct and quite independent of each other. As it should be, you always should have your risk assessment function independent of operational pressures. However, if they are too separate from each other, they must communicate. And what Greg did when he joined Venter is he created a space for us, or an environment for us, where those 2 can slightly overlap. And that's where the magic started happening, is in this space where it overlaps. And what we saw happening is when the scientists within the risk assessment space start to talk to the managers within that risk management space, that they come up with really ingenious solutions of how to fix food safety problems in the business. What I want to do now is I really want to discuss the risk assessment function a little bit more, because that'll give you more clarity of where whole genome sequencing is applied currently. So within our risk assessment function, we do research way on the fundamental side of the research continuum, but we also then take the research we do there and we slowly develop it all the way into the applied space. Now, to give you an example, the research we would do typically in that fundamental space would be describing hazards and describing them in detail. We then take that information and we take it a little bit further, and we also then develop the analysis methods where we'll be able to detect those hazards. And then we go a little bit further and we go into this applied space where we then go and we start to develop control measures for these hazards. And this is really where we started using our whole genome sequencing. Now, we went on a journey for about, Nigel, is it 2 years now, with the New Zealand Food Safety Centre, because we had no capability in whole genome sequencing, and we really had to start to understand this technology and build that in-house capability. And this is where we started deploying it. And it's much in the way, Martin, that you've described it as other industries would use it. And I would also refer you to a review paper that's recently been published by Yakadisen et al. And that's a nice review paper giving you insights on where industry apply whole genome sequencing. And it really is for improved root cause analysis. And Martin has given you quite some detail on that, so I thought I won't go into that any further. What we have done within Venter, though, is we've gone a little bit further than just the improved root cause analysis, in that we started teaming up the whole genome sequencing with other technologies, which I'm not going to share with you today, unfortunately. And we use these technologies to come up with solutions for our risk managers. Now, if you now go back to our risk managers within Venter, they will say to you that this technology gets used to make the invisible in the plant visible. So in a nutshell, we use whole genome sequencing to strengthen our quantitative risk assessment and to make it really solution-focused. Right. What I'm going to do in the next few minutes now is I'm going to give you an idea of where we see application of whole genome sequencing in the near-term future. So that's probably the next 2 to 3 years. And hopefully, Nigel, as you said this morning, we'll hopefully still work with you on this to further develop our capability in this area. Right, so in the context of quantitative risk assessment, if I take you back to that fundamental side, we see application of whole genome sequencing really in describing population dynamics of specific microbial populations. And for us, it will be describing those dynamics at the various steps within our value chain. We then see using that technology in conjunction with other omics technologies. And as you know, that whole genome sequencing is just one of the omics technologies that's advancing quite a bit. There are several others as well. And we'll be using these two technologies to really describe the phenotypic responses of these populations at those steps. That's really at the fundamental side. We then have to take it a little bit closer to the applied side so that the risk managers can use it. And that's where the predictive microbiology comes in. And as Martin described, you can't use traditional predictive microbiology to do it on those big data sets. You absolutely need to apply new technologies in that space as well. And we've been working quite hard to upskill in advanced analytics as well as artificial intelligence to really work on those data sets. Why do you need to do this prediction? Because it's quite important for us to understand how the biome in one specific area will affect the biome in another area, and then again in another area, so that we can employ or deploy some control measures to change those biomes the way we want them at those specific steps. What I've done here is I've given a quick example to say, well, we need to understand the biome in the soil, on the grass, on the farm, and understand how that impacts the biome on the udder of the cows, for instance. It's then important to understand how the biome on the udder will in turn affect the biome in the raw milk. Now, raw milk, for those of you who don't know, that's the milk pre-pasteurization. Right, once we understand that, the next step is to understand, once that raw milk comes in, how the environment in the manufacturing plant and the biome in the environment, how that will impact, again, on the process, the in-process samples, and then finally how the environment, as well as what came in with the raw milk, how that impacts the final product biome. Right. Unfortunately, for those microbiologists in the room, this is where the road ends for the microbes in many of our products, such as UHT. However, we know and we've learned through the years that even if you get rid of your microbes within that step, the packaging step, you still have their metabolites that remains. And those metabolites could be enzymes. Those enzymes could be lipases or proteases, that's heat stable. And they continue on and they continue to affect all the next stages in your value chain. And the things that we're really interested to understand is how those metabolites that remain would affect our ability to differentiate our product based on food safety and quality, our ability to make claims on our packs, what the impact would be on the sensory functions of the product, the functionality of the product, but also the shelf lives of those products. Right. I want to finish off my presentation by giving you a glimpse of where we see the future post 3 years of application of whole genome sequencing. Now, the first two bullets that I've got there, you'll see, has got to do with the human and the gut biome. Now, I honestly believe that as we go forward, we'll learn more about how the human genome and how the gut biome impacts a person's susceptibility and how susceptible they are to foodborne disease as well as other illnesses. The interest for us is how our food products can be applied to enhance the position of the gut biome to protect people against foodborne illness and against other illnesses. And that's really where the next one comes in there, our living products, and understanding what happens within our fermented products, such as cheese and yogurts, etc. If we understand what the microorganisms in there do, so the ones we add and even the ones we don't add, how those organisms behave to, first of all, protect those products against foodborne pathogen contamination and colonization, but then also how those specific organisms contribute positively to the microbiome and the composition of the microbiome, again, to protect the humans against disease. We believe there needs to be quite a bit of advancement that needs to happen in both predictive microbiology, as I mentioned, in the artificial intelligence, and as well as advanced analytics, but then also the multiomics, which I've mentioned, to predict those outcomes. Also important for us, similar, Martin, to how you've described harmonization between government authorities, etc. We see that there needs to be absolute harmonization between us and our industry partners. So you can imagine a world where we determine a specific risk profile using whole genome sequencing of the products we produce. We sell that off to other companies which use it as ingredients in their products. They will also be using whole genome sequencing to determine the risk. And for us, it's really important that those two determinations are the same. And then last, as you called out as well, Martin, risk communication. So we've got this evolution of whole genome sequencing. We've got the evolution of the predictive microbiology. We're seeing an evolution of how risk managers use the technology within our plants, but we also need that evolution of risk communication as well. Right, I'm going to stop there.